My greetings, dear students. So in this new video, we will discuss some formulas of derivative for standard functions. Let us first of all write the formulas. First is derivative of constant function, that is 0. Second, derivative of x power n, that is n x power n minus 1. Third is, if we have dy by dx of ax plus b power n, then the formula is n ax plus b power n minus 1 into a. And the fourth one is d by dx of a power x, that is a power x log of a for a not equal to 1 and strictly greater than 0. Fifth is derivative of if we have e power x here, and very easily we can put a by e, we get e power x, and log of e is equal to 1. And the sixth one is derivative of log ax, and that is 1 upon x log a. Here a is the base and we have to take it greater than 0. And the seventh is dy by dx of log x with base e, and very easily we know that when base is e, log of e becomes 1 and the answer is 1 by x. And we have 6 formulas for derivative of trigonometric functions. Okay, let me write it here. Dy by dx of sine x is cos x, and dy by dx of cos x is minus sine x, and dy by dx of tan x is secant square x, and dy by dx of cot x is minus cosecant square x. And we are left with 2 formulas. Let me write them here. Dy by dx of secant x and dy by dx of cosecant x. And here the formula is secant x tan x, and this is minus cosecant x cot x. So we have to remember 7 this plus 6 this, total 13 formulas. These are standard formulas. We need these to solve further numericals. Very easily we can prove these formulas using first principle. So you can check my previous video for derivative using first principle. Let us start the application of these formulas, and the first question is, let fx is equal to x power 4, and question is find its derivative. Then very easily, how much is f dash x? That is dy by dx of x power 4. So we compare this with the second formula, and you see what is the value of n here? 4. So it is 4 into x power 4 minus 1, that is 4x cube. So which is the answer here. Let us discuss one more numerical. Let we have y is equal to root x, and very easily we can write it as y is equal to x power 1 by 2. Then dy by dx equals dy by dx of x power 1 by 2. And as you see here, when you compare this with this formula, what is n? 1 by 2. And the answer is 1 by 2 x power 1 by 2 minus 1. That is 1 by 2 x power minus 1 by 2. And the answer is 1 upon 2 x power 1 by 2, which may further be written as 1 upon 2 root x. Answer. I hope you got an idea how we have solved this. Numerical B, let y is equal to 1 upon cube root of x, and very easily we may write it as 1 upon x power 1 by 3 or x power minus 1 by 3. And when we take its derivative, dy by dx is equal to dy by dx of x power minus 1 by 3. So once again we make use of this formula. So that is minus 1 by 3 x power minus 1 by 3 minus 1. So we can easily take LCM here. Minus 1 by 3 x power. How much it becomes? Minus 1 minus 3 by 3. That is minus 4 by 3. So this is the answer here. Okay, let us discuss one more numerical. Let y is equal to 3 power x. So here dy by dx is equal to which formula we use here? Fourth one, this one. So what we have a here? 3. And what is the answer then? 3 power x log of 3. Answer. See, very easily, if we know the formula, we just have to put the value. What is a here? 3. 3 power x log of 3. Okay, let us have one more numerical. Let y is equal to log 3x. So which formula we use here? This one. So when you compare, what is the base here? 3. So a is equal to 3. So dy by dx of that is d by dx of log of x base 3. So how much is the answer from this? 1 upon x log of 3. That's it. Next numerical. Let fx is equal to e power minus x. And question is, find its derivative using first principle. So again, we know the formula. F dash x is equal to limit h tends to 0 f of x plus h minus fx divided by h. And as fx is e power minus x, how much is fx plus h? So very easily we can put the value e power minus x plus h minus fx as it is upon h. And very easily we can see that this can be written as e power minus x, e power minus h, e power minus x upon h. As you see, we can take common e power minus x and we have e power minus h minus 1 upon h. So when we convert in this form, we can easily judge that this is a formula we already have. So for that, what we need, this and this and this should be same. So before that, let us take this outside because limit applies on h only. And to make it same, what we do, we multiply by minus 1 and divide by minus 1 here and here. And also as h tends to 0, minus h will also tends to 0. So we write minus here. So we can put the value of this. What is that? 1. And hence the answer is this. Okay, one more numerical. Let it be fx is equal to 3x square. So again we have to find its derivative by first principle, and the formula is limit h tends to 0 f of x plus h minus fx divided by h. So putting values, it becomes limit h tends to 0 3x plus h square minus 3x square upon h. Next, we will open this square. It becomes h tends to 0, 3 power x square plus h square 2xh minus 3x square upon h. So as earlier, very easily we can take this 3x square and this 3x square common, which can be written directly outside. Limit h tends to 0. So what we are left with? 3 power h square plus 2xh minus 1 upon h. So can we see any formula here? Yes, we have a formula. What is that? Limit x tends to 0, 3 power x minus 1x is equal to log of 3. I hope you got the formula. So we make use here, but for that we need this power denominator and this should be same. But what we are getting here, h square plus 2xh. So let us multiply by this and divide by this. So you see 3h square plus 2xh minus 1 upon h square plus 2xh, and also we will multiply by h. And as you see, so we are converting this in the required form. Now as h tends to 0, h square plus 2xh will also tends to 0. How this tends to 0? Because this is a multiple of h. And if h is 0, whole of this term will tends to 0. So very easily this may be written as limit h square plus 2xh tends to 0, 3 power h square plus 2xh minus 1 upon 2xh. And here we can take h common and write limit h tends to 0, h times h plus 2x by h. And this h cancels. And how much is this? Log of 3. 3x square into log of 3, and when we put h 0 here, this is 0 plus 2x. And the final answer is 2x, 3x square, log of 3. Answer. Let us now find the derivative of fx is equal to sine square x by first principle. First of all, as usual, we write the formula. H tends to 0, x plus h minus fx upon h. Putting the values, this is limit h tends to 0, sine square x plus h minus sine x upon h. So this is sine square. So this is a square minus b square. Putting the values, okay, a square minus b square is a plus b, a minus b. So it may be written as sine x plus h minus sine x and sine x plus h plus sine x whole divided by h. And as you see, when we put h tends to 0, what we get here? Sine x minus sine x, which is 0 by 0. But here we get 2 sine x. That means we have to work on this part. Okay, what can we do here? So very easily we know CD formula, sine C minus sine D. Let us use that formula here. And by that formula, we have 2 cos C plus D, that is 2x plus h by 2, and sine C minus D, this minus this, so x will cancel, h by 2 whole by h. And second part, limit h tends to 0, sine x plus h plus sine x. And further, this may be written as limit h tends to 0, 2 may be written outside, cos 2x plus h by 2, and limit h tends to 0, sine h by 2 by h, and putting h 0 here, so it becomes sine x plus sine x. And here you see how can we make the perfect formula. We have to multiply by 2 and divide by 2. And also, as h tends to 0, h by 2 also tends to 0. So this is 1 when we are left with this 2, and which will cancel with this 2. Let us see what we are left. Again putting h 0 here, so we are left with cos 2x by 2. Again 2 cancels, cos x, and here the formula 1, and here we have 2 sine x. So combining all these, 2 sine x cos x very easily, which is again sine 2x. Answer.